Our next exponent rule is called quotient of powers. It means what happens to our exponents when we have a division problem. So just like before, we're going to model out our various exponents and then simplify them into getting our final answer. We're going to do several problems modeled out, and then I'll show you the shortcut. So looking here, 9 to the 5th is on top. So that would be the number 9 written out 5 times. On the bottom is 9 to the 2nd. So that's written out 2 times. And then we're going to cancel out a top and a bottom number. And we can see that we have 3 9s left over. So 9 is our base number, and then 3 becomes our new exponent because that is how many 9s are not canceled out. Looking at number 2, I have 2 to the 7th power, which is going to be my top number. And then across the bottom, we have 2 to the 3rd. Once they're modeled out, we're going to pair up and cancel out the matches. The base number 2 stays the same, and we have 1, 2, 3, 4 2s left remaining. And so 4 is our new exponent. For our third problem, we have the value 10 with an exponent of 10. So we're going to list that out 10 times. On the bottom, we have 10 to the 6th. So again, we're going to list out that base number 6 times. Once both the top and the bottom are modeled out, we can cancel out the matches and see that we have 10 for our base with 4 remaining on top, so 10 to the 4th power. In our next problem, we have 3 to the 10th, so we're going to take our number 3 and list it out 10 times. Across the bottom, we have our base number 3 with our exponent 5. So we're going to model it out 5 times. Once everything is modeled out, we can cancel out our matches, leaving our base number 3 used 1, 2, 3, 4, 5 times. So 3 is our base and 5 becomes our new exponent. For our next one, we have the base number 12 written out 8 times to represent our exponent. On the bottom, we have 12 to the 1st power, so only 1 12, meaning we can make only 1 match to cancel out. The base number 12 is left 1, 2, 3, 4, 5, 6, 7 remaining, so 7 becomes the new exponent. Number 6, we have 3 to the 9th power, so we're going to write out that number 3 9 times. On the denominator, we have 3 to the 2nd power, so we're going to list it out twice. Finding our 2 matches to cancel out, leaving us with a base number 3 used 7 times. Now, in order to find a shortcut, we're going to look back at our exponents. Here our exponent was 5, and here our exponent was 2. Because we're crossing out our matches, we are taking them away, we are subtracting the exponent values. The 5 on top minus the 2 on the bottom gives us 3, which is our final answer. Here, the exponent 2 to the 7th on top and 2 to the 3rd on the bottom, we can subtract together to get 4, which is our final exponent from the problem. On our next problem, our exponent 10 minus our exponent 6 gives us an exponent of 4. So continuing that shortcut, we can take our 12 minus our 3 to get a value of 9. So 7 is our base and 9 is our new exponent. Here we're going to take our exponent 15 minus the denominator exponent 4, which gives us 11. The base number stays the same, and 11 is our new exponent. Here our exponents are 9 on top minus 1 on the bottom. 9 minus 1 is 8, so the 11 is our base number, and 8 is our new exponent. Here we have 19 on top for our numerator and 17 on top for our denominator. Subtracting gets us a value of 2. 3 is our base number and 2 is our new exponent. 15 is our numerator exponent. 8 is our denominator exponent, which subtracting gives us a value of 7. 8 is our base number and 7 is our new exponent. In number 12, 21 is our numerator exponent and 16 is our denominator exponent, subtracting to get a value of 5. 6 is our base number, with 5 being our new exponent. Along the bottom row, 20 is our numerator exponent, 9 is our denominator exponent, subtracting those to get 11. 15 is still our base number, with 11 being our new exponent. 17 is our numerator exponent, 16 is our denominator exponent, which gives us a subtraction of 1. You can write this answer as 9 to the first power, or you can simply write it as 9. 9 with no exponent is also 9 to the first. Either answer is correct. For our last problem, we have 30 as our numerator exponent and 14 as our denominator exponent. Subtracting gets us a value of 16. 24 is our base number and 16 is our new exponent.